All right, so I have v of x equals 2 times x cubed minus 7. As I decompose that function v of x, I get x cubed times 2 plus a negative 7. I will go in the opposite direction to then build my inverse function. So that will give me plus 7. So I will have x plus 7 times 1/2 raised to the power of 1/3. So that my inverse function would be z of x. So z of x is my inverse function to y of x. Now to determine if I actually built this function correctly, then I need to make a composite function. And I first make my composite function with v composite with z of x. So v of z of x. And so what my initial v of x is, this is the x, this 1/2 x plus 7 raised to the 1/3 power. That was my inverse function, and I plug that in for the x of your v of x, and I get this. So looking for my 1 pairs and my 0 pairs and trying to figure this all out, I see that I have this 1/3 raised, I have a cubed and a 1/3, and those are opposite. That is a 1 pair. So I make that 1 pair. So now I have simplified that expression to this. And by simplifying it to this, then I am able to also use the, associative property to regroup the plus 7 plus a negative 7 to get the 0 pair. So I use the associative property to regroup that to get the 0 pair. And then I'm left with this expression. And continuing to look for my 0 pairs and my 1 pairs, I see 2 times 1/2, which is a 1 pair. So that whole expression is equal to 1, so I am left with x. And I believe that tells me that this is the inverse function, because I'm getting the identity of v of x, which is x. So then I attempted to do it the other direction, z of v of x. And I get this expression where my original z of x is this, and I'm going to plug in my v of x for that x, so that I get 1/2 times the quantity 2x cubed plus a negative 7 plus 7 raised to the power of 1/3. And again, looking for my 0 pairs, I have, since I'm looking for my 0 pairs, I have the negative 7 plus 7, which is a 0 pair. Then I'm left with this expression, and I have the 3 times 2 raised to the 1/3 power, and that's a 1 pair. So that I am left with this. And again, I have another one pair and I'm left with x. And I think that tells me, yes, this is the inverse function.